All right, so we have learned how to convert from rectangular form to polar form. Let's figure out how we're going to go in the opposite direction. So let's go back to our basic example where we've got, let's say this time we know the magnitude, right? Because we have polar form. So we're going to know the magnitude, and let's call that V. And we know the angle, right? We know the angle between the vector and the positive x-axis. We'll call that theta. We want to know what this red section is in our vector. That's going to be B. We want to know what this vertical length is. Oops, I'm sorry. I reversed that. This is going to be A because it's in our x direction, and this is going to be B because it's in our y direction. Okay, how do we figure this out? Well, again, we're going back to basic trigonometry. With this reference angle, this is opposite, this is adjacent, this is hypotenuse. So if I want to know what B is, and I have the hypotenuse, I'm using O and H, I'm using sine. So B, what we would say is we would say that the sine of theta equals O over H, equals B over the magnitude. So if I'm just solving for B, I can cross multiply, and I get B equals the magnitude times the sine of theta. Let's look at A. A is the adjacent side with respect to theta. So I'm trying to find the adjacent side. I have the hypotenuse, A and H. That's cosine. So the cosine of theta equals A over the magnitude. Again, solving for A, cross multiply, A equals magnitude times cosine of theta. So these are our formulas to express vector V in component form, like so, or like so. We're trying to find A and B when we're given the magnitude and the direction. So A is equal to magnitude times cosine of theta, and B is equal to magnitude times sine of theta. Let's see these in action. All right, so first, magnitude is 12, the direction is 70 degrees. Express the vector in component form. So, we could sketch this real quick, see what it looks like. It would be something like this, right? Because this angle has to be 70 degrees and this length has to be 12. So it's in the first quadrant, so I'm going to be expecting both components to be positive. So let's see if that's the case. This is super simple with the formulas. The A component, or the A, which is the x component of the vector, is equal to 12 times cosine of 70. And B, the y component of the vector, is 12 times sine of 70. I'm going to flip over to Desmos. 12 times cosine of 70. 12 times the sine of 70. I'm going to check real quick to make sure I am in degrees mode. I am. And this gives me my answers, okay? So I've got an x component, or A, equals 4.10, and y equals 11.3. Written another way, this would be 4.10, 11.3, or we could say 4.10i plus 11.3j. All right, another one. Express the vector 2 and then 225 degrees in component form. So again, in this form, this is my magnitude, this is my direction. 225 degrees is way over here. So that's this vector that has a length of 2. But I don't have to worry about that. This is just plug and chug with my formula. I'm just going A is 2 times the cosine of 225, and B is 2 times the sine of 225. No thought required. Go over to Desmos. And I'm getting negative 1.41 and negative 1.41. And if I look up at my graph, that's what I would expect, right? I'm going down and to the left, so both the x and y components should be negative. I'm writing this in kind of the normal way that we express vectors. I can do it this way, or I can do it this way using i's and j's.